Hi, everyone. Just wanted you all to know that this episode of the Modern Digital Enterprise was recorded in February of this year. And then the pandemic hit, and we focused on COVID-19 related materials. Just in case you're wondering why we all seem so happy and full of joie de vivre, as if we hadn't a care in the world. There's actually a lot of James Urquharts in the US, more than I would have thought.
More than I would have thought too. I know. It's like, you do a Google search or whatever, the Google Alerts thing on it. And there's a sheriff in Maine and a sheriff in Washington, both of which are named James Urquhart. So I get all these weird crime reports. And actually, one guy's a PR guy for the police department, or for the sheriff's department, and the other guy's the sheriff.
It's better to get the crime reports about other people than for that have like a criminal name.
Well, yeah,
that looks bad.
All right, I guess let's just get started. Welcome to the Modern Digital Enterprise, the digital transformation podcast from Anexinet, part of the Anexinet podcast network. I do have a chicken story for today, or at least a chicken analogy. This is something that I started doing and then I just didn't stop doing it. So
James, just so you know, Steve has chickens. Like he's not just like someone who likes chickens. He actually owns chickens in his backyard, has a coop and everything. So
I don't think you need to give me a justification for the chicken story. I appreciate it.
Yeah, well, wait till he's done. You may feel differently in a minute.
So what happens with chickens is they don't lay all winter. They're just freeloaders. And it's related to like the cycle of how much sunlight you get in a day and so forth. It's pretty crazy. Today I went out there. One of the chickens was missing and I thought could be in the coop with an egg. And sure enough, chicken laid an egg, first egg in like a few months. So that's exciting. But I was thinking, and help me out in trying to get people to understand the concept of event-driven architecture. Is that related to backyard chickens? An event-driven sort of notification system, something that we could definitely use, would maybe indicate like when the chickens have run out of food or water. They have like tubes of food and a tube of water when those have run out. Or if a chicken has laid an egg, would that maybe also count as an event that we could receive a notification for? Something else we're thinking about is the chickens will squawk. They'll go crazy if a hawk flies by. Something to alert us of the presence of a hawk so we could maybe analyze it and try to identify trends to see if hawks come at a certain time and then maybe eliminate that threat more easily. Or even something like when the coop needs to be cleaned out, some indication of that. And the reason that this is even a thing that I've been thinking about is because we bought the chickens literally as therapy chickens for our daughter who has anxiety, and my wife and I are both allergic to fur, so we can't have like normal type pets. And she did a farm camp here in town. They have chickens. She fell in love with chickens and went on a pro-chicken campaign for about a year. So that's how that happened. So now it's 3 years later, and it seems to have worked, which is the good news and bad news. My daughter's much less anxious than she was 3 years ago, which is fantastic. But on the flip side, she no longer cares about the chickens. I don't think I've mentioned this to anybody in the office. But yeah, she really couldn't care less about the chickens at this point. So we have to really badger her to do these chores. So does that represent like sort of how an event-driven system would work?
Yeah, I think, first of all, it's weird that you talk about the first thing popped in my mind is like, yeah, eggs really are like events in the sense that they represent a state change within the chicken that is then communicated to the outside world, right, in a sense. But yeah, really the way to think about it is that, I think the hawk analogy is a good one in the sense that one chicken sees the hawk, it starts squawking, everybody else picks up on the squawking. All the other chickens are now aware that there's a hawk in the area and we've got to be, run for cover or whatever it is. And, the difference would be if every chicken kept asking every other chicken, hey, do you see a hawk? Is there a hawk out there? Anybody else see a hawk? Has anybody else asked the sky lately if there's a hawk? It's not the way nature works. There are times when we ask for a response and get a response. But a lot of nature is that a signal of some change of state, some change of situation that people care about is propagated through mechanisms that either repeat the event or translate the event into a different signal and send that signal out, or aggregate a set of events into a larger event that communicates. And so, all the things that you mentioned in terms of taking care of the chickens, those are all really good ideas for things that are related to events. So rather than you having to go poll your coop for, are there eggs? Do I need to clean it? Do I need all this stuff? You might have sensors that let you know that, the filth level in the coop has reached DEFCON 3. It's time to send the daughter out and reacquaint her with the chicken. And in that situation, I think that, I think those are the kinds of things that are good analogies for what business is going to do, because really a lot of what we're going to get in terms of events are going to be events that are either triggered from some sort of sensor of something that's going on in the world, the physical world that the business cares about, or is going to be the propagation of some sort of digital signal that's either initiated by a human being or is a continuation of a digital signal that's come from some other source. And this is why, I think integration is such a big part of the conversation about event-driven systems, which I'm sure we'll talk a lot about later.
So I think we have our title for the podcast today, The Internet of Chickens, instead of The Internet of Things. Brought to you by National Geographic and VMware.
So, the IOC.
The flow of chicken.
Yeah.
The flow of chickens. Yeah.
Yeah, I usually like the flow of chickens, from the refrigerator into the oven,
into your mouth,
onto the plate.
Yeah.
So, and that is one option that you now have if your daughter doesn't really care about the chickens anymore. It's dinner time.
Oh, she knows. She knows. We've made that thread very, very clear to her. James, thanks for indulging that running bit. And let's introduce you now. So today we have James Urquhart. James is a technology strategist, evangelist, and communicator. And James, why don't you tell us a little bit about what you're working on now and how you got to where you are in your digital journey?
I appreciate that. So I am a long-time distributed systems professional and buff. I'm one of those guys that's lucky to be working on something that I enjoy very much and enjoy studying very much. I started early in my career as a programmer. Actually, my very first part of my career was as a systems support person, because I swore I would never program professionally when I graduated college. I just thought it sounded like a dull job. And then was introduced to a company where I was sort of, hey, you know how to program, here, take this code. And I'm kind of forced to get it back into it again, and discovered I loved it. And I was in an industrial setting, so I was very quick to discover that distributed systems were kind of really critical to sharing information across, a wide variety of people that needed to share that information. So I got into distributed systems early, back in the day, before even client server really took off. We were doing a lot of just stringing things together. I worked for a company that wrote its own record manager on disk, even before any sort of database capability, really. So anyway, so from there, I went through a series of consulting jobs. I worked on a bunch of different kind of early distributed systems doing that. And then ended up at a company called Forte Software that did 4GL for distributed systems, which was an amazing education. I mean, we tackled problems. This is back when, a large scale system had maybe 10,000 users and 1,000 concurrent users or something like that, or 100,000 users and 1,000 concurrent users. I mean, it was very, very, very low scale stuff compared to what we know today. But it was a big deal back then. And so I learned an awful lot about what it took to scale, to do availability, to do operability of systems in addition to just programming them. And that led to a number of jobs. I stayed in the vendor world, and I worked at Sun Microsystems for a while and did a lot of stuff for their systems. If you were a java.sun.com user back in about 1999, 2000 timeframe, and were forced to change your username or forced to change your screen name, you can blame me. I was the guy that ran that project and made that go through. But anyway, and from there, a number of different vendor jobs related to both infrastructure level stuff. So I worked for a company called Casat that did data center automation and did workload deployment automation. And that led to cloud. And I've worked for a number of companies doing data around distributed systems, doing a number of other things as a sales engineer, as a product manager, and have ended up at Pivotal, where I'm a global field CTO. My role is to work with senior executives on understanding the strategy of using distributed systems and using modern application development techniques to build and deploy those systems. The other thing I'm fairly well known for in the industry is I wrote a blog that started when I was at Casat and lasted for about 6-7 years before I ran out of things to say on cloud computing. So an early cloud computing blogger. Ended up at CNET for a while with that blog and ended up at GigaOM at the very end. But it had, according to other people and other people's measurements of these things, it had a fair amount of influence on cloud computing in about 2009 through 2015-ish kind of time frame. And so I really enjoyed doing that. And currently I'm focusing on this concept a lot more of distributed systems in terms of event-driven systems. And I'm really, really interested in what happens when the interfaces for connecting to event streams and interpreting events become commodity, become very, very standardized and very, very understood. And my belief is that it's the next big major disruption to the way our industry works and the way the business works in general. It's the next major digital disruption, in my opinion. And it's one that I'm taking some time to study very carefully and even writing a book about right now.
You did a lot of our work for us, which we really appreciate. We put together a little deck of topic ideas and sent a video of your keynote, Path to Production as a Service. And I'd love to hear more about when you talk about path to production, what got you into this idea and what exactly do you mean by it?
Yeah, it's a great question. So as I kind of started to look at development platforms, which are increasingly becoming important in the way that distributed systems get built and deployed, I started to ask myself the question, what is the role of the platform? And working at Pivotal, one of the things you realize is that enterprises are very quickly adapting a sort of new organizational layer, very small one, not a major deal, but a platform team, an organization that's building a platform for developers to consume. And the question is, what is the role of that platform? If we've already got the ability to provision servers and to place our container workloads where we need to, what is the role of this platform thing? And good folks at Pivotal already done a fair amount of thinking about this. So the term path to production was already kind of floating around a bit when I got there. For me, the aha moment was realizing that the developers don't want capacity. If you ask a developer what they want from the network, they'll tell you they don't want to know it's there. They just want to be able to say, hey, I need a connection from this client to this service with the following criteria applied to that connection. If you ask them what they want from storage, they don't want to know what kind of storage is. They want to know that if they output text to a file, that they can get it back later. Or if they output, or if they use a database interface, that, hey, the database data is there when they go to query for it again later. So that concept of the capacity in which the services that developers require and the actual code that they write runs is becoming less and less something that they care about. What is it they care about? Well, they care about getting that code into production. They care about the application, the state of the application, the state of the application's data, and having that not only get to production the way they want it to, but stay in production the way that they want it to. And so that it starts with this concept of give me a path to production for my code that's the least amount of friction possible. But when you really start to work with developers and understand in more depth what it takes, you begin to realize it's about taking an idea, a concept, all the way from being a concept through all the steps necessary to get it in the hands of customers and get feedback on that concept and make sure that it's there in a way that customers can consume it. So now your path production goes beyond the idea of continuous integration or continuous deployment, and includes things like how do we declare an idea and get it financed, and how do we do that with the minimum amount of friction possible. And then once we built the code, how do we get it through compliance and security regimes that are necessary? How do we make sure that what we've built not only works well for the customer, but integrates well with the rest of the business and helps create a customer experience that goes beyond just what we built ourselves? And so there's a lot of testing, there's a lot of feedback loop elements that begin to become important to removing friction from, and a lot of automation, by the way, that is important to removing friction for the developer. The idea of path to production as a service as a title comes from the question, what is the role of the platform team in the enterprise? And the answer is it's to provide the best path to production for developers in that organization possible as a service, to provide all the technology necessary to make that path to production possible as a service. So it's not only things like Pivotal Cloud Foundry, which provide automated mechanisms to package a distributed system, deploy it, and then maintain that state of deployment, regardless of what might happen in the environment that it's running in. But it also includes things like continuous integration, continuous development tool, and pathways. It includes things like technology services, message queues, databases, event buses, those kinds of things that are services that developers want to consume via API, but are not really infrastructure. They're not technical infrastructure. They're not hardware infrastructure in any way. So somebody's got to operate those services and make them available. And then the last thing would be the building blocks you use to put together all the pieces necessary to make the application run. So things like the underlying operating system layers, the different libraries you might need to do different functionality in your environment, the different networking configuration elements that are available to you, different storage connectivity elements that are available to you. All of those things are building blocks pieces that you want to be able to bring together really easily at a very, very low friction way for developers and minimize the toil required by developers in order to be able to consume those things. And still provide some flexibility, which is a whole other part of the conversation. But so that when I talked about that in that keynote, really all I did was I did a simple parable. I won't go through the whole thing here, but it's a simple parable that just tells the story of getting goods to market and having obstacles to overcome and getting those goods to market. And the moral of the parable really is, if you just deliver technologies to developers and say, here's our standard database, here's our standard message bus, here's our standard CI/CD tool set with no defined paths in it. All you're doing is providing a technology base, but you're still forcing the developer to build their own path to production, and they still have to deal with all the friction required to do that. A really good platform team is like, it's like a government that builds a highway system for the country. They build common paths that work really, really well. They work with developers to help developers adapt their development, their application problems to work well in those paths where possible, but also have the flexibility to create some side roads, create some alternative paths where necessary for those developers when absolutely necessary, but are hyper-focused on eliminating friction wherever they can and bringing the development community to an environment where it's really easy and really fun to build and continuously improve code over time.
So James, when you're describing this, it brings up, in my mind, one of the big challenges for digital transformation, really of any sort, which is we're going to do something different than we're doing it today. And a lot, at least from my experience, and whether or not this genericizes over everybody is to be debated, but there's a lot of different development teams that at different times have selected their own sets of tools, sometimes because there is no platform team to set the foundation for them. And they'll go get Jenkins, or the old stories of I've got a credit card, so let me put through for a little bit of AWS and get some stuff done outside of the structure that's in place internally, and they build their own processes. So you maybe could talk a little bit about that cultural transformation that has to happen in terms of, how do you maybe get people to buy in that, hey, we're going to do something a little bit different than you're doing it today, gather that feedback so that you can maybe get a few folks who are helping evangelize this new method and kind of talk about why it's good and get all of those teams that are out there to adopt and really get the most advantage out of this new platform that you're providing. Because it's the type of thing where, hey, you tell me that this is the best way to kind of take away a lot of the challenges of building your own path to production. But sometimes if I'm comfortable in the way that I'm doing it, I don't even want to hear that because I'm going to go through this hump of learning the new thing that is, at least for the moment, for that transitory point in time, is going to crush maybe my productivity a little bit. And hey, if I've got a new release coming up, I can't afford to go through that transition at this point in time. So maybe you could talk a little bit about how you bring this on and get the teams to buy into this new path.
I'll start by just sort of asking the question, how do the cloud providers get people to use the cloud, right? Which is, I think one way to look at it is if you're offering path to production as a service, you have to be thinking of it in terms of this service had better be better than the alternatives. The way that you do it and the way we work with customers to do that, we find one application that's got some value to the company, but that's a good starting point for transition. And we work closely with those teams, and ideally we actually pair with those teams over the course of that initial transformation and do the work necessary to either convert an existing application or build from scratch a new application using cloud native techniques and get it deployed and get it operating, and then even begin to work through the second iteration and working through a regular iterative cycle and a product focused mindset for building that application. And when we do that, if we do that successfully, there's a tremendous amount of velocity of new value that continually gets deployed by those teams. And that becomes very attractive to the businesses that are consuming applications, the business units that are consuming application, business owners, but also to the other development teams. And so the number one way to roll out a platform in an organization is to build something better than what the developers could do on their own. They may be resistant to agree that it's better until there's some data to back it up. But if you have a path production as a service and it's kind of a SaaS product like experience, then you need to go to market plan, and that go to market plan really has to be about building some success and then trumpeting that success to others and helping to make it seem just ridiculous to go your own way when there's this incredibly powerful environment that's incredibly successful available to you within the organization. So that's really the number one thing. There's no mandated way to really force people to understand the value of this stuff. They have to see it in action. And that's why you start small so that you're not disrupting the entire organization, but you trumpet and market the heck out of every success so that people begin to understand the value of what you're delivering. And I will tell you, every digital transformation I've been a part of, whether at Pivotal or before, every digital transformation I'm part of has taken at least a year. And in the course of that first year, it sucked at that point. It's been uncomfortable and awkward for people who don't understand all the pieces apart and where all the value is coming from. There's stuff that's happened that hasn't shown its value yet. But if you stick with it and you do the right things and you're making decisions on behalf of the developers to make the developers' lives easier, you come out of that year maybe a little less, maybe a little more, but you'll come out of that year with an experience and a capability that there is absolutely no way anybody would want to go back to the old way. And it's consistently, time after time, that's been the case. The only time I've seen it fail is when senior management has refused to take the journey with the development team in waiting to see that year play out and waiting to see that value come forward. So I'd say, it's equally important to get senior management to understand that what they're looking for is continuous value delivery, not predictability a year out of what they're going to get, but a firm knowledge and even assumption that they are going to get new value delivered to customers every day or every week, or whatever the time frame is. But in very small time frames, they're going to continuously get new value elements that are going to be delivered to customers, or at least in some enterprises you can't quite do it every week, so at least into a staging environment that the business can evaluate in some depth, and then package up to be deployed to customers at some point in the future. But that's the critical pieces right there. It's just success breeds more success, and you have to start small and then just market the hell out of that success.
Can you actually trumpet some successes right now and give us some real world case study type examples where you were able to smooth path to production for some clients?
Sure. I mean, I think the most exciting one is we work with the Air Force, and they have a team of folks that has gotten extremely good at building and deploying cloud native applications and continuously improving those. There are applications related to the operations of the Air Force that obviously I can't go into any details, but key applications that they were able to basically replace projects that had taken over a year or a couple of years and it had cost hundreds of millions of dollars and really not delivered anything that the Air Force valued, and able to, in a number of a few months, like a half a year, be able to turn out applications that the Air Force finds extremely valuable. That has brought more and more mission demand into that team and has helped grow that team. They also have more formal work underway in terms of expanding the influence of this approach to software development within the Air Force. And then there's some new projects that the president's put underway that are also looking at the way that they're going to deal with software development as they go live. So we've had a lot of success, I think, in really sort of making cloud native something that the Air Force uses as a strategic weapon to be able to out automate their mission enemies. Another good area to look at is if you look at Dick's Sporting Goods, one of our customers. So they have, I don't know, if you're a Dick's customer, you may have actually seen this. They have completely revamped the way they do software development over the last 2 to 3 years. They are actually, turning out value on a very constant basis. And they did something super, super cool at our recent conference, at the Spring One conference in 2019, where they stood up on stage and they demonstrated the operational value of having a platform approach by literally failing over their production search functionality while people were sitting in the audience searching for things on the website, and failed it completely over from Microsoft Azure to Google Cloud Platform live on stage in a matter of a minute or so. And that demonstration shows that, the developers didn't have to do anything crazy to make that work. There was a lot of testing, obviously. There's a lot of automation. There's a lot of sort of, checking to make sure that there's redundancy in the right places. But that capability that a good path to production platform provides is that the developers get this incredible capability that they feel very comfortable showing off on stage with very little effort on the part of the developers in order to support that. And I think those are two really great examples. We have numerous examples of companies that have. One more example I'll give you real quick is related to the operational side, is a bank, a very, very large bank, that is in the process of getting to the point where, because the platform and those building blocks, the building things with those building blocks is so automated as a part of their path to production, they're getting to the point now where they're going to be able to repave their entire environment, every application running on the platform every day, meaning all new security credentials, all new, access credentials, all new VM images or container images in this case, freshly grabbed from secure sources, libraries, usually with any new CVE patched within a matter of hours or days, and able to grab all of that and rebuild their entire environment with that secure thing, run it through all the testing and everything every single day, so that if somebody does break into a system, they've got maybe 24 hours to do something with it before everything changes on them and they've got to do it all over again.
Oh, that's awesome. Thank you for that. And you mentioned containers in there. So I'm just wondering what is the role that containers play to improve path to production?
It's a very important concept. So there's a couple of different ways to look at it. So one is from the perspective of what developers' units of work are, right? A VM is a massively overplayed grain of work for a developer, like having to deal with all the OS elements, all the network connectivity elements, all the storage connectivity elements that you have to do to manage a VM is and define and configure a VM. That's a huge amount of extra overhead and toil for a piece of code that might, in theory, be, a few dozen lines of code if it's a certain kind of thing. It becomes a really crazy thing to deal with. So what a container does is a container allows you to essentially define the executables of an application and the direct dependencies of those executables in a way that you just assume the operating system is there. But you get your own namespace, your own protected world, and from a call perspective, that allows you to say, hey, I'm going to use this version of Java. I'm going to use these libraries related to it. And then here's my code, and package that up and just find a place to run it for me. So that's one aspect. One aspect of it is that the packaging is a much better story. And packaging at the process level is a much more atomic level. It's not the most atomic level for a developer, though, because if you really get into what developers work, and they work in terms of functions, right? They break down their code in blocks of different functions. So you can see why serverless becomes a very popular concept that people will continue to work with and play with, because that becomes much closer to the very local deployable unit of atomicity for a developer. But the other way to look at it is in terms of speed. VMs take a long time to power up. Even newer technologies to help address that issue, you're still talking about an order of magnitude or 2 orders or 3 orders of magnitude longer to launch a VM than to launch a container. A container just is how long does it take your executables to start? That's basically the question that you have to answer to launch a container. So from that perspective, when you're looking at test-driven development, the ability for your environment to do everything very quickly without a lot of wait time for various functions to complete is incredibly, incredibly important. And so containers are a much better unit of deployment and delivery from a speed perspective as well, because you're able to fire up and evaluate and test things in orders of magnitude less time, and with most importantly, much less wait time for where you're waiting on other resources to do their thing before you can actually run your tests. So I think containers will continue to be a part of the substrate of applications for a very, very long time. We've always used .exe files, other things as units of deployment for executable things in the past. The only difference, here is that you get all the dependencies and stuff very nicely packaged as well, which is also really important. But I think from a developer path to production perspective, over time, I'm guessing that having to have a large scale set of functions that you bring together and figure out how you're going to package things to be optimal will start to give way to things that are much more focused on functions or small sets of functions, and that the container will kind of drift into the background. It'll be important from those that are operating the platform, but it won't be very important to developers in the long term. Now, long term being 5 to 10 years probably, but you can see people who don't deal with containers at all out there, who have web, fairly large scale web properties that they don't even touch containers hardly at all. So it's important, it's critical, it's a piece of infrastructure, it's a piece of capacity definition, really, when you look at it.
Great, thank you for that. And you also mentioned that serverless plays a role here. And we actually did, I think about a year ago, we did a podcast episode on AWS Lambda. So I'm just wondering how serverless plays a role in improving this path to production.
I hinted a little bit about it, right? It's that unit of atomicity. And, this is a good transition as we go into just discussing a little bit about event flows and how event-driven architectures change things for the positive. So a lot of the work that we do with functions, when you look at it, is to go get some data, do some decision making and or manipulation of that data once we receive it, and then to take some action, either through the user interface with the user, or making calls to other systems, passing either new sets of data or the existing data forward for another purpose. When you look at it from that perspective, a lot of the database retrieval kind of things we do are really to go back and retrieve a state change that we want to then be able to react to and take action on. It's not really we're asking a question and looking for a response to that question. What we're doing is like, okay, we're getting the next thing off of a digital queue to go work on. And then we're going to work on it, and then we're going to pass it to the next step in our process. When you have functions like that, if you could just have a queue and go get the next thing off the queue and then pass it to another queue that for the next thing that's going to work on it, that's a much more natural flow for those kinds of problems. And so this is really where I think functions will take off, is so many things are really about keeping data moving in real time, or not really real time as in every instant, but in a timely fashion, and as fast as the system wants to process things, it's there and it's getting processed and it's being taken care of. And those flow problems are really going to benefit a lot from the ability of having queues and then having actions that can take actions on those queues and stringing those together into patterns of work that represent what we want out of those data flows and the work we want from those data flows. A friend of mine, a gentleman named Mark Anderson, very sharp futurist, talked a lot about the fact that flows are great, but flows are worthless unless there's interaction. So you need flow and interaction. And the function part is really that interaction part. So serverless is going to allow us to build these applications that are very flow centric. And the functional pieces of that are going to be the critical interaction pieces of that are going to, it's not the only, Lambda is not the only form of that, by the way. I mean, you can do things with step functions. You can do things with, even with some of the Kinesis streams functionality that allows you to make some decisions or take some actions in terms of data transformation and things like that. But you're going to have these functional components, these interaction components that are very important. And a raw function gives you the most flexibility in terms of what you can do with that event and that data and how you can respond to that. So it doesn't mean that we replace completely ever the idea of a RPC kind of call. There's a lot of things that require RPC types of calls. For instance, establishing a connection to a stream to begin to receive events or data streams, that requires an RPC call. You need the client to initiate that action and get a response. But I think you'll see a larger number of things of the way that state changes move through business and state changes move through both economic and social networks, becoming more and more event driven. And therefore you'll find that a serverless functional driven approach is going to make a lot more sense over time.
So you may have touched on this a little bit, but I'm wondering about your process. At Anexinet, we have a strategy ideation process that's pretty standard from client to client. We don't really change it that much. We might customize it a little bit depending on who the actors are and what the functions and behaviors are. But in general, the process remains the same. So another exercise we use is called Day in the Life, where we'll follow companies, employees, or users around to determine pain points or where additional efficiencies might be possible.
Yep.
So I'm wondering if your process is kind of similar in implementing this
absolutely
speeding path to production. Do you have to go in and analyze every step, or are there some elements that can be plug and play? And are you hoping to create sort of a library of those elements to make it even easier for you to implement these efficiencies?
Yeah, so from a ways of working perspective, and so the processes that you use to determine an application scope and requirements, the ways you would define an event flow over time. We do a number of activities I think sound very similar to what you're talking about, right? We have a part of what we bring to the table for VMware now is the concept of pivotal Labs, and Pivotal Labs is really, it's a 20-year-old services organization that's helped customers similar to what you're talking about in terms of building applications using modern approaches. What I will say is I think what you're talking about is very important kind of things, and I think you guys are very much doing the kinds of things I would expect a top-notch organization to do, which is to work with the customer in a couple of different areas. So the first thing about path to production is it's really about a value stream, right? When you look at what it is from beginning to end, is how does value get created from a concept and idea to what the customers get in their hands. And so we do an awful lot of value stream analysis type of activities with our customers and understanding, similar to what you're talking about with the day in the life, understand the way their processes work, understand how work might sit in queues waiting to be worked on, and what can be done when work is actually being done to make those things more efficient. And looking for ways to kind of reduce lead time or reduce process time to begin to optimize things more. One of the areas we find is the biggest headache in the world, especially in regulated industries, is the lead time, the time things sit in queues for compliance regimes and security regimes is sometimes the biggest pain you will ever experience, right? It's not that the upfront before they even get started at queue is bad, although that's sometimes the case. But okay, so then they're going to hand it off to their white hat vendor or whatever it might be to do penetration testing. Okay, well, that's got to sit in their queue for a week. And by the time you get through things, you have like a 3-month process where the actual work being done by anybody might be a week of that, or a week and a half or 2 weeks of that, of actual work being done. And so we look for things like that where automation can help eliminate things sitting in queues and can also speed up the processing time of the actual tasks that need to happen. We also do things when we work with developers in identifying their application problem with customers, a lot of design work and a lot of things like event storming, where a process by which you sit down and you talk about the way messages move between entities in the problem space and talk about the way that work flows through it. And that can help a lot in defining what types of subsystems you need to build in order to solve that problem. So absolutely, I think the process has to be one that's about continuous learning, and you don't stop once you're not trying to come up with a marketing requirements document or products requirement document that you then hand off to development. That's a disaster. You're trying to come up with a continuous way of continuously asking questions of the system and the users of the system to continuously learn about what can be improved, and then prioritizing that work for the developers so that the developers can always be looking at the next thing of value they can deliver to the users.
Great, thanks. And in case you're wondering why Glenn is so quiet, I don't know if he texted you, but his daughter has a fever. So, oh, there he is. I think
I'm here. I've been listening. I'm in the car right now.
Ladies and gentlemen, Glenn Gruber now in the car on his way to picking up his daughter.
Oh, man.
That's a news alert.
Well, I hope she gets better fast, man.
Yeah, our kids. One of our kids is always sick. Now it's like a constant. It's a flow of germs from one child to the next. That's a very efficient flow, apparently, in our house. So, in the few minutes we have left, why don't we move on to talking about your idea of flow and how it will change the way we use software?
So right, so we talked a little bit about the event-driven stuff and how that is the sort of the movement from a source where the source can trigger action for a consumer. The idea that a state change can be communicated outwards, that rather than being pulled for by those that are interested in the state change, is a really critical concept because it allows for actions to be taken as quickly as the system wants to take them. It could be done in as close to real time as possible. I worked on a system that did real user measurement for a very large number of online retailers. And that system would receive every single browser interaction, receive data at the time that the browser interaction occurred, and immediately begin to, once it received that data, begin to process it for analytics purposes primarily. People could see things like, how did that campaign that we're running right now, how's it going? Do we need to tweak anything as it's happening? Which was a brand new concept for retailers. They used to have to wait 24 hours or more for the results of a campaign. So that kind of action and being able to take that action as quickly as possible, that's really novel and powerful and new and great. But when you begin to bring the idea of having standard standard interfaces and standard protocols by which connections can be made and these streams can be passed between things, you begin to open the idea of maybe people recombining these data streams in ways that were unexpected and great new value that weren't known. So think about the way we took HTTP and information, and we used HTTP and linking information to create incredible new forms of value that we depend on today, that are hugely important. The way that that Wikipedia has become critical, but beyond that, to the way that Google takes us to a website that then maybe points us to another website that gives us the piece of value that we're looking for. We would never live without hyperlinking right now because it's so critical to the way we do so many things. In the same way, I think that linking activity is kind of the future. And so, one of the key things I focus on in the writing I'm doing right now is the idea of having a worldwide flow, having a network that's sort of an organic network that's built up by all the different ways that activity is connected over the global economy over time, and how that's going to evolve to be and what that impact is. And I think it's going to be tremendous. I think you're going to have new forms of business that are going to have major impact on the way things work. And I think you're going to have new forms of computing, solutions for around monetization of streams, around aggregation of different stream aspects, around news reporting based on automated receiving of streaming information and so on, that are going to be really critical to the way that business evolves. And I'll just kind of leave with the most radical thought that I've had so far at this, which is, if you think about a way a corporation is organized and why corporations are organized. Corporations came into being because you needed to bring the resources together to do some large complex task together into the same organization, so that you had access to them as needed and are able to organize them to complete whatever process is necessary to deliver that business value. But imagine if you could take each step of your process and decide, is this core to the business? This is something that needs to be differentiated and we need to do very differently. Or is this something contextual, as in, this is a standard accounting step, or this is a standard purchasing step. And you were able to actually use events and string these event systems to get connections together to be able to outsource all of your contextual stuff as a small step, as a small functional step of your business at a time, and be able to basically, what happens to the structure of a corporation when that happens? And are we able to break down this need for these giant monoliths through event-driven systems? And just a question I'll leave out there, because I think it's just a fun thing to think about.
When you're saying that, like, one of the things that made me think of, like one of the big impacts on innovation and on disruption, was modularization. So a lot of what you just described is modularization, but really like at a data level.
Yeah.
So is that kind of an accurate read of kind of like where you're going with your thought process?
I think both in terms of modularization of data sources and modularization of data processing algorithms and capabilities. Absolutely. I think my friend Simon Wardley, who's another great futurist that I love to listen to and talked with, he's made a bet that by 2030 we'll see a company that has $1 billion valuation based on a single function. Now, I'm not sure that I agree with him on that, but it's an interesting thought. Could somebody have a core, like a contextual function that they do incredibly well and make incredibly cheap and easy to use, and they build a $1 billion valuation off of people being able to use and consume that single function? So that kind of thing to me is really, really intriguing. Because it makes a lot of sense on the one hand that everybody doesn't replicate the same sort of basics. We already see that in software with open source, with libraries, shared libraries that we've been using forever in different programming languages. It'd be interesting that the business library begins to become something where it's a little bit more standardized. And there's a lot that has to happen. I think this is a 5 to 10 year vision easily before that becomes the case. But nonetheless, you can absolutely see that if we do manage to standardize and agree on a standardized interface and a really simple mechanism to connect to streams and to understand what we have to interpret from the streams and find all the ways we can use that data valuably, then I think you can see very quickly that it creates all kinds of interesting opportunities out there in the market for entrepreneurial minded people and for businesses that want to change the economics of how they do things.
It's all interesting, and it's also like what you talked about, in terms of streams and monetization. There's, well, certainly like one thing that came to mind is like Twitter, which is how we met originally. They've been trying to monetize that stream for quite a long time, and to various levels of success. But I think that there's been a lot of people who have thought about analytics as a service, like someone came up with, where if I am a company and I have information from a distribution perspective across a number of different vendors, or I have, if I'm an ERP company or supply chain management, and I'm seeing all of this data flowing through my systems for different clients, and I can anonymize that, then I can look at how well is each individual purchasing organization for a particular widget doing versus all of the people who are buying those across all of my customers, from a SEM perspective, and then being able to resell that back out to folks so that they can evaluate how well their performance is. But I think that you're talking about taking this to yet another level, in terms of what type of streams of data you may have available to you and how that might get monetized.
There's a whole conversation to be had about this, how these systems will organize and scale based on the way complex systems organize. Sounds very, very academic, but the point of it being that the likelihood that we can pass every single piece of information through every single pipe, to every single potential endpoint doesn't make a lot of sense, right? You're not going to have a large aggregator of data pass every single core starting sensor event or software activity event all the way through to every end user. You're going to have aggregation that's going to occur. And I think one of the things that will happen is there'll be a lot of value generated and a lot of business value generated by being able to figure out the way to represent activity at a detailed level in a more aggregated level so that can be consumed downstream at a volume that makes more sense for those users that want to know what that value is. You see it already in the stock market. And people who take the stock streams and present all kinds of analytics data on stock information as a service that they sell to stock traders and others. I think you could see very similar things across a wide range of data that business already generates that they could turn into event streams that could then become valuable to somebody else and then turned into value for yet another customer.
So what are the things that you think have to happen to get us to a point where we can follow through on all these things that you've talked about? Just from a standardization perspective, so that we can get to that commoditized stream, or a common way where people can consume from just a SOA architecture and to where we are today, to moving towards microservices. Like, a lot of progress made, but over a long period of time. Like, what are the types of things that have to be done? Is there like a W3C type committee looking at this, just like you mentioned about HTTP?
There's a lot that has to happen to make the total picture come into play, but it starts with figuring out what these standard interfaces are and standard protocols. And it turns out that the Cloud Native Computing Foundation, CNCF, has a working group that spins out of their serverless working group that's focused on the concept of cloud events. So the cloud event standard that they published version 1.0 of in November is basically a wrapper, a simple HTTP-based wrapper that goes around either specific JSON type data types or around binary data types that describes what's being transmitted as that part of the stream. And so And so it gives you a way of making sure that you can understand what you need to do in order to be able to interpret the stream to a point. The payloads aren't defined. The payloads aren't predefined in any way. So you do probably need to go to the vendor sending the data to understand how to interpret the actual payload. But in terms of interpreting, what type of data stream it is and, what type of technology you need to be able to get that payload out of the stream, that stuff is very, very clearly and very well defined, including things that allow you to forward that information on in a way that the source isn't lost in the process of doing so that you can have aggregators and processors that may receive some streams and do something with it and then forward that data on. Really good important stuff that you need for the protocol. So this is the actual protocol for being able to get events through these streams. But the other part that we're beginning to do work on is thinking about what are the interfaces and what are the ways in which not only you can connect to a stream, but you can also search for and find a stream of a certain type. And again, this is one group that's looking at the problem. There's no guarantee that this will be the winning solution. I'm very supportive of what they're doing. They're making a lot of the right decisions. It's a very smart community, people from a lot of well-known vendors that everybody knows and loves. But it may come from another source. It may turn out that some open source project somewhere comes up with the super simplistic way of connecting to streams that can be easily wrapped around Kafka and AWS could use easily and others could use easily. That turns out to be the winner, just from sheer de facto adoption of the service. But we need those standard interfaces and those standard protocols kind of to kick off this world of integrating by events and at a larger scale. Then there's a ton of infrastructure that has to evolve from it. I know people who are working on things like dial tones for event streams, where essentially, you connect into essentially a meta network that is entirely in terms of topics and connecting to stream sources. And makes it extremely simple for you to just sort of say, hey, rather than type in an IP address for the destination I want to go to, I type in a topic name and I'm connected to that stream, right? And I know people who are working on application development environments that are almost completely no code, that just know how to look at streams and give you very simplistic ways of interpreting what you want to do with those streams and how you want to route information or how you want to transform information as it moves through your application environment. And there's a tremendous amount of other opportunity. As I said, there are people who do business intelligent ways of aggregating information, people who do new ways of reporting information. All of that value is really, really big. But it really starts with taking where we are today with the event-driven systems, which are still super infancy, super baby steps, way before crossing the chasm kind of stuff. But taking those and beginning to understand how to evolve them with integration in mind, with the idea of having an unknown party be able to connect to the stream and consume that stream in an intelligent way. And so I think that's the next 3 to 5 years is where you're going to see that start to evolve. And then the 5 years after that will be not only the bringing of the technologies we discover we didn't know we needed in to make that commercially viable, but also the more mainstream adoption of the idea of integrating the event. That's why I say it's 10 years out before people talk about, quote unquote, the worldwide flow in sort of a, news people talk about it on the morning show kind of thing. That's way out. But certainly for businesses to pay some attention to it, it's a pretty big deal in the 5-year time frame. And I think if you want to plan for this, if you want to be prepared for this, understanding your event-driven architectures with explicitly asking the question, how would we make the stream available to outside parties, is a really important thing to start to do today. And that you could do today that, you may guess wrong on the exact mechanisms, but if you're understanding the problems you would have to solve to make it viable at a large grain level, you'll at least make architectural decisions today that will set you up well to be able to take advantage of flow technologies when they do appear.
What kind of incentive do you see for a company to reveal their stream or to provide streams for outside?
That's a very use case dependent, but I think that the more general question is, if you're a company working for profit,
can you monetize the stream? Actually,
monetize the stream is one area. Although you don't always have to monetize it to get value back as a business, right? A big thing for you is building ecosystem to, you're taking more of a platform strategy approach, and you want to build an ecosystem that improves the footprint of solutions that your product applies to. And so you want third parties to make money off of what you do as well. You may offer streams for free on the condition that people are, a part of your ecosystem in some way. But also I look at this from the perspective of governments who may want to make streams available because they're valuable to the public and the public are paying for it anyway, or they're valuable from a strategic interest perspective from a country that wants to be more appealing for certain industries than others. So they make valuable streams available to attract those industries to, your jurisdiction. I see it from a nonprofit perspective with, making the kinds of data available that allows you to complete your mission easily, more easy, but also at the same time to communicate to founders the value that's being generated by your charity or by your government NGO or whatever it is, to make that information more clear to those that are providing funding, so that that feedback loop to improve the efficiency of the value being delivered by the organization based on the funding is tightened up as well. All those things are really, really valuable, and I think are things that will generate interest. There's also, I can see hobbyists making information available from crafts or maker kind of projects and things like that, making that available to others to be able to consume, and somebody stumbles across something that's really, really valuable for a large set of the population. Those things are all really, really incredibly useful. But I think, the biggest ones I look at are building ecosystem, I think, is a really, really big one. Tightening up the supply chain or the data communication chain required for your business to be effective is another one. So increased efficiency. And customer experience is a big one. Like making sure that customers have a really consistent experience, regardless of which of your business units or applications they're interacting with within an organization, is a big driver for event-driven today already. Real-time inventory in retail is a good example of that, where your customer will know exactly what's available, and they won't be surprised if they go to order that thing we thought was available is not available. But another big piece of it is that when you tie it with outside organizations, that a group of businesses that are working together can have an extremely consistent experience for that customer, where the customer feels like they're one known entity for a trip they're taking. Everybody in the travel itinerary has a very consistent view of where they are, what they've been doing, what needs they've expressed in the course of the trip, and can use that information to work to provide better service and perhaps even upsell capability to those customers as they're going through things. So a lot of opportunity, but I think, really that customer experience, the efficiency, and then innovation of new business capabilities are really the three things I focus on the most.
Awesome. I'm at my daughter's school, so I got to run. But I do want to ask one question that you can answer after I hang up. So I bought that book, Scale, that you mentioned,
Okay.
by Jeffrey West. Very, very interesting so far. I'm only about 20% through, so a lot more to go. But one of the things that you started to talk about in terms of scaling this up, and you having all of these different flows available, and you couldn't possibly consume it all. Maybe you could just talk a little bit about how you think it ties into the idea behind the book Scale, which
Sure.
So far all I've gotten is that there are certain patterns that are sort of repeatable as you scale in a linear fashion, but then there are other patterns that as you're bigger, it's not always if I'm twice as big as someone else, or some other species, as the book tells it, that I don't need necessarily twice the energy to live, that there is some sort of asymptotic scaling fact that's in here. It's not strictly linear. So maybe you can chat about that a little bit.
Yeah. So Jeffrey does an incredible job of kind of laying out why we see certain patterns exist in complex systems, especially complex adaptive systems that have a lot of something flowing through the system. So in a city, it might be, you might look at it from the perspective of traffic. In an economy, it's money. Obviously in living things, in our bodies, it's blood. In trees, it's sap and energy, the way energy gets transferred. And so you see these patterns where, because of these asymptotic relationships between the size of something or the volume of something versus the amount of X that's needed to support it, you see some really crazily interesting relationships that start to pop out and patterns that show. So first of all, trunk, limb, branch, leaf, right? Core arteries, and then the limb arteries, and then capillaries and all that other stuff, blood vessels, capillaries. Cities have freeway systems with then major surface streets, with then the residential streets. You see these patterns where you have concentrated flows for large amounts of stuff that then are kind of broken out as less of each thing is needed or has to be delivered. And you see things start to break down, but you see the movement of stuff come kind of through these cores. I would expect with these event flows, we'll see something similar, where we would start to see central core ways that the core large-scale things that are needed are going to move through things. One way to look at that is the internet. The internet is sort of the freeway system. That's probably true. The network is one way to look at it. But another way to look at it would be the businesses that might aggregate, like say, look at the stock markets. The stock markets you could think of as the trunk for equity exchanges. And so you might have the same thing for stocks related, in this case, not equity stocks, but in terms of volumes of things moving through, say, different supply chain elements or different, say, I'm trying to think of a really good example and I'm blanking, but you can see that there's an opportunity as this flow kind of builds up and becomes more central, that there might be central things that receive ultimately huge amounts of the data related to a problem space and are kind of core to the way that data then propagates back out to others in the world. And I certainly think the big three cloud providers are going to play a major role in this from an infrastructure perspective, and they may play a major role in this in terms of being some of the core business capability for certain flows as well. They may provide services that handle really large scale problem sets. But the other thing that's interesting about this is that asymptotic relationships you end up with some things that actually don't vary very much depending on scale. So the one I found the most fascinating was, for every mammal on Earth, from the very smallest shrew to the very largest whale, it turns out that we all have very, very, very similar blood pressures. Like within a certain small percentage range of each other, we have the same blood pressure. So in the same way, I would think that the amount of, or the volume of events flowing through any of these things, the volume of actual events may actually turn out to be something that doesn't vary greatly, so that you don't have, one stream that you subscribe to, and you end up with a billion events a second that you have to deal with. But in fact, there's going to be some limits there. And when you hit those limits, that's going to begin to force a situation where aggregation is going to occur, and that a stream will have sort of all the streams, regardless of what kind of event sources stuff, might have the same sort of maximum flow rate, regardless of what type of data it is, regardless of what type of source and what it represents. And that in order to flow it to larger and larger numbers of people, you end up having to, at some point, more and more events and more people, you end up having to aggregate more and more layers in order to make that maximum level and stay below that maximum level. So I really, as I look at this, I get very, very interested in, things like that, where are the asymptotic relationships going to come from? I don't know that I'll be able to predict them in any seriously detailed way at this point in time, but I think a lot about the ways that people can begin to look at and try to identify those situations early, so that when they build systems with an understanding the kinds of evolutionary patterns that are going to make sense, that are going to likely to make sense in this world, and begin to understand when limits are hit, that maybe more aggregation is required, or maybe or smarter routing of events is required, or maybe limitations to the clients in terms of how much they can actually consume is understood. So these things are interesting, but Geoffrey West's book, in my opinion, is a great roadmap for what to think about as you think about how the world of event-based integration scales over time.
Awesome. And, this conversation is also making me think about whether it would be applicable to like global weather patterns and
Sure.
global climate change patterns and the identification of maybe like catastrophic weather events or as a
Yeah,
result.
that's one of the first use cases that introduced the concept of flow to me that I knew about was somebody who posed the question, what happens if we were to put sensors all over the place for everything environment related, and then stream that data and make it available for a number of purposes? What would it mean? We already kind of have that. I actually know of a group working on edge technologies that is working with an insurance company who is using the smog sensors built into a lot of the traffic systems that are deployed in major cities, and using the nitrous oxide level measurements to figure out whether there's an actuarial relationship between people's health and the number of buses that drive by every day. I mean,
Right.
kind of crazy. There's a lot of stuff here that you look at. There's a lot of ethics questions too, by the way, that go with this, but a lot of interesting stuff that you look at and you go, wow, I never thought of connecting the number of buses going by to somebody's insurance rates. But it's quite possible that that's the kind of thing that we discovered and are able to adjust in real time by this flow data.
Yeah, that example you just gave really helped paint a picture for me. So I appreciate that one in terms of, consolidating data streams that seem unrelated or that just the connection hasn't been made yet. I'm wondering if machine learning is being used or if you have plans to incorporate machine learning as a way to accelerate the process of maybe identifying which streams can be used, together to
Yeah.
create new data flows and so
Yeah,
forth.
that's so there's two parts of that question to me, right? One is the use of ML and AI. What it's really, really good at is pattern recognition and decision making based on those patterns, right? And so as an interaction technology, absolutely, I think AI will be critical. I think a large amount of these streams are going to go through some system that's going to look for patterns that it learns to understand better and better over time, and use those patterns to make decisions about the next processing step, or whether or not to raise a signal downstream to the next group or whatever. So when we talk about that scale problem, right, one thing that you could do is put AI in front of a raw stream and figure out which of those signals do I actually want to propagate downstream to eliminate some of the noise. But the other part of the question then is, and I've thought about this many times too, right? I for a while there, I was playing around with the idea of just taking two random technology terms and like building a giant spinning wheel, or two spinning was a spin one, spin the other, and go, okay, how would I combine technology A with technology B, and see if that came up with an idea for an entrepreneurial thing. And in a lot of ways, I think you could look for patterns potentially in the types of streams that are available in the data coming through those streams, and saying, is there a correlation that maybe somebody should go take a look at? A lot of correlations in the world are completely coincidental. They're not related to each other at all. But you might occasionally find that correlation that goes, holy, I did not understand that the amount of spending on new tires in cars is heavily related to the profitability of body shops, right? In a related area. And so I could use that to make investment decisions, or decide where to open new stores. You can use correlations to potentially figure out some things that are useful in business, or you can make all kinds of tragic mistakes assuming things are correlated. But I think AI has a huge opportunity in a lot of ways to help with identifying patterns that people should take a closer look at, and also making decisions based on patterns that we already have an understanding of what we want to do, depending on what we recognize or don't recognize in those patterns. I do see that taking off. And then 5 to 10 years from now, where will the technology be? I can't tell you that. So maybe it'll radically change the picture even further. And, I can't wait to see. That's why I love being in this business, because if you ever stop learning in this business, you're not paying close enough attention. It just changes in wonderful ways so quickly that you got to be on top of it. You got to be constantly looking.
Absolutely. Well, James, this has been a terrific conversation, and I want to thank you for tweeting at Glenn so that he was able to bring you on. And also, lastly, I just want to give you a chance to plug your upcoming book.
Yeah. So, date isn't set yet, but I'm working on a book right now for O'Reilly that is focused on this concept of flow and integration via events. And so certainly welcome your viewers to look in the fall timeframe for that. And then also, or listeners, I should say, and then and quite similarly, if folks are interested in reaching out to me to talk about this topic or have ideas or technologies that they think are relevant, I can be reached on Twitter quite easily, just at James Urquhart, JamesurQuhart, and I'm very active there and happy to hear more if people have things they want to bring up.
That's great. Well, thanks again for joining us today.
My pleasure, guys. Sharp questions, and I appreciate the insight you guys brought to it as well. Appreciate it. It was a very fun conversation.
Oh, thanks. The pleasure's ours. Take care, James. Bye-bye.
Is that it? That's what you want me to hang up?
That's it. Well, then I get a little tag where I just say and thank you for hopping on to another episode of the Modern Digital Enterprise, the digital transformation podcast from Anexinet, part of the Anexinet podcast network.
As a leading technology consultancy and reseller, Anexinet helps clients provide a complete digital experience for customers, employees, and end users. We accomplish this through our holistic approach, which encompasses all aspects of today's digital journey, end-to-end. Anexinet partners with top technology vendors like HPE to offer products and services that enhance the digital experience across customer engagement, enterprise mobility, cloud and hybrid IT, and analytics. Because great digital experiences rely on the smooth operation of all interconnected elements. From strategy through execution, we deliver custom multi-channel applications, including web, mobile, chat, and voice. With self-service apps for customer loyalty and enterprise apps that streamline internal processes, now you can reimagine legacy applications to propel your business forward. Anexinet also helps you embrace modern cloud and hybrid IT infrastructure to provide a seamless experience at every touchpoint, empowering you to recover quickly from disaster, scale to meet demand, and automate systems for perfect performance 24/7. And to maximize your competitive advantage, we ensure you always deliver the best experience possible by continuously honing your digital solutions through data-driven insights. So, how do you know if your business has what it takes to provide the complete digital experience? One that sets you apart, maintains competitive edge, and turns users into passionate fans? Simple. Just give us a call. Together, we can deepen engagement and make every digital experience remarkable.